The future of business intelligence. The role of data science and AI integration. In the rapidly changing digital landscape, businesses are continually seeking ways to sharpen their competitive edge. At the heart of this evolution lies business intelligence, BI, a technology-driven process for analyzing data and presenting actionable insights. Traditionally, BI focused on aggregating historical data in dashboards and static reports. Today, however, the integration of data science and artificial intelligence, AI, is transforming the field into a dynamic, predictive, and even prescriptive resource for decision-makers, heralding a new era of cognitive BI. This article explores the evolution of BI, the growing impact of data science and AI, the benefits and challenges of integration, real-world applications, and future trends shaping the next generation of business intelligence. The evolution of business intelligence. Historically, business intelligence emerged as a set of reporting and querying tools designed to help business leaders understand what had happened within their organizations. Early BI systems were built around static data warehouses, where large volumes of data from disparate systems were consolidated and reported on using spreadsheets and basic dashboards. Although these systems provided valuable retrospective insights, they were limited in their ability to predict future trends or recommend concrete actions. The last decade has seen BI evolve from mere descriptive analytics into a more sophisticated discipline. Advances in computing power and the democratization of data have enabled organizations to harness not only structured but also unstructured data. Businesses began to demand more agile and interactive tools that could support not just historical analysis but also forecasting and decision support. This shift set the stage for the integration of data science, a field that uses statistical methods, advanced analytics, and machine learning algorithms to uncover hidden patterns in data, and AI, which automates and augments analytical processes. Together, these technologies are reshaping BI from a passive reporting tool into a proactive decision-making partner. The rise of data science in business intelligence. Data science is the engine that powers modern BI systems. Unlike traditional analytics, which often depend on manually created reports and static dashboards, data science involves the end-to-end process of data collection, cleaning, exploration, and modeling. Organizations now face the challenge of harnessing massive datasets, from customer transactions and social media feeds to sensor outputs and beyond, and turning them into actionable insights. Data science's role in BI is multifaceted. First, it provides the tools to process and analyze vast amounts of data quickly. Advanced statistical models and machine learning algorithms can identify trends, outliers, and hidden correlations that were previously invisible. Second, data scientists develop predictive models that forecast future outcomes. For example, by analyzing historical sales data together with economic indicators, a company can predict demand fluctuations and adjust inventory accordingly. Third, data science drives prescriptive analytics, which does not just predict what will happen but recommends specific actions to optimize results. This integration of data science into BI systems also encourages a culture of experimentation. Data scientists often use iterative approaches to refine models and test hypotheses, thereby continuously improving the accuracy and relevance of insights delivered to decision-makers. As a result, modern BI platforms are no longer static repositories of past performance but live ecosystems that are constantly evolving based on new data inputs and analytical methods. AI integration in business intelligence. While data science lays the groundwork for advanced analytics, artificial intelligence takes BI to the next level by automating many of the processes that were once manually intensive. AI tools leverage machine learning, ML, natural language processing, NLP, and computer vision to transform raw data into actionable intelligence at unprecedented speeds. Predictive and prescriptive analytics. One of the most significant contributions of AI in BI is its capacity for predictive analytics. By training machine learning models on historical data, AI can forecast customer behavior, market trends, and operational risks. For instance, AI-powered models can predict customer churn by analyzing factors such as usage patterns, service inquiries, and demographic information. Moreover, prescriptive analytics, which uses AI to recommend optimal strategies, is becoming increasingly popular. Instead of merely flagging potential issues, AI systems can suggest corrective actions, whether it's a targeted marketing campaign or an operational adjustment in the supply chain. Natural language processing for self-service analytics. Another transformative application of AI in BI is natural language processing. NLP enables users to query data repositories using plain English or any language, rather than complex query languages. This development democratizes data access within organizations, allowing non-technical users to generate insights quickly. Imagine a marketing manager asking, "What were our top-performing campaigns last quarter?" and receiving an instant, data-backed answer. Such self-service capabilities not only speed up decision-making but also organically drive a data-driven culture across the organization. Automation and cognitive capabilities. AI's automation potential in BI extends beyond analysis to areas such as data cleaning, anomaly detection, and real-time reporting. Automated data cleansing tools can identify and correct inconsistencies in large datasets, while AI algorithms constantly monitor operational data to detect unusual patterns that might indicate a problem. Moreover, cognitive analytics adds a layer of understanding to BI. For example, advanced systems can synthesize insights from financial reports, news articles, and social media feeds to offer a comprehensive view of market sentiment, information that was once relegated to separate departments or manual analysis. Benefits and challenges of integration. The integration of data science and AI into BI frameworks offers several valuable benefits. First and foremost, it enables organizations to move from reactive to proactive decision-making. Instead of waiting for end-of-quarter reports, managers can now obtain real-time insights that drive immediate action. Enhanced predictive capabilities mean that companies can anticipate challenges, be it a surge in customer demand or potential supply chain disruptions, and respond accordingly. Another significant benefit is the greater personalization of insights. AI algorithms can segment data according to various criteria, allowing tailored recommendations for different parts of the organization. For instance, personalized dashboards can empower sales teams with region-specific forecasts while giving production managers insights into manufacturing efficiency. However, achieving such integration is not without challenges. One major hurdle is data quality. AI and data science models require clean, consistent data. Inconsistencies or gaps can reduce model accuracy significantly. Organizations must invest in robust data governance, ensuring that data is not only collected at scale but maintained with high standards of quality and privacy. Integration complexity is another challenge. BI systems are often built on legacy platforms that may not easily support modern AI tools. Transitioning to an integrated system may require significant IT overhauls and change management initiatives. Additionally, the skill gap presents an issue. The integration of data science and AI in BI requires skilled professionals who understand both advanced analytics and business contexts. Companies must focus on upskilling staff or hiring new talent to bridge this gap. Finally, ethical considerations must be addressed. As AI systems increasingly drive decision-making, ensuring transparency, accountability, and fairness becomes paramount. Organizations must establish ethical guidelines for AI usage and address potential biases in algorithms to avoid reinforcing unfair practices. Case studies and real-world applications. Several industries are already reaping the benefits of data science and AI-integrated BI, setting benchmarks that other sectors are eager to follow. Financial services. In the finance sector, banks and hedge funds use AI-driven BI to detect fraud, optimize investment portfolios, and predict market shifts. Machine learning models analyze transaction data in real time, identifying suspicious behavior that might indicate fraud. Automated trading algorithms use historical patterns and real-time market data to make split-second decisions that maximize returns. Healthcare. Healthcare providers have begun integrating AI into their BI systems to improve patient outcomes. For instance, predictive analytics in combination with electronic health records allows hospitals to anticipate patient admissions and allocate resources more efficiently. AI-powered diagnostic tools assist radiologists by flagging anomalies in imaging data that might require further attention. Such systems ultimately lead to faster diagnoses and more effective treatments. Retail. Retailers use advanced BI solutions to drive personalized marketing campaigns and optimize their supply chains. AI algorithms analyze customer purchase histories and online behavior to create tailored product recommendations. Real-time analytics enable retailers to adjust pricing dynamically and target promotions to the right audience at the right time. This not only improves customer satisfaction but also drives sales growth and inventory efficiencies. Manufacturing. In manufacturing, AI-integrated BI systems are critical for predictive maintenance. By analyzing sensor data from machinery, these systems forecast equipment failures before they occur, reducing downtime and repair costs. In addition, data-driven quality control systems ensure that production remains consistent and defects are minimized, leading to higher overall efficiency and lower operational costs. Future trends and predictions. The trajectory for business intelligence is one of continuous evolution, where data science and AI integration will deepen, creating systems that not only inform but also autonomously drive decision-making. Several trends are poised to define the future. Cognitive BI. The next stage is the development of cognitive BI systems that can mimic human thought processes. Such systems will be able to learn from new data inputs continuously, adapt to changing business contexts, and even generate strategic recommendations autonomously. Cognitive BI will transform the role of decision-makers from data consumers to overseers of a self-improving analytical ecosystem. Augmented analytics and self-service BI. One of the most promising trends is the expansion of augmented analytics. Tools that leverage natural language interfaces and AI-powered visualizations enable non-technical users to explore data intuitively. As these platforms become more user-friendly, even small businesses can harness powerful analytics without the need for large, specialized teams. Edge computing and real-time data processing. The future will also see more integration between cloud-based BI and edge computing. With sensors and IoT devices proliferating across industries, real-time, localized data processing is essential. Future BI systems will blend edge-derived data with centralized analytics to provide instantaneous insights that drive faster decision-making cycles. Ethical and transparent AI. As AI becomes increasingly central to BI systems, there will be more focus on ensuring ethical practices. Regulatory bodies and industry standards will likely develop frameworks to ensure transparency, prevent bias, and protect data privacy. Organizations leading on these fronts will build greater trust with their stakeholders, which in turn will drive adoption of AI-powered BI solutions. The role of cloud and hybrid architectures. Finally, the gradual shift to cloud-based and hybrid architectures is set to continue. These flexible environments support rapid deployment of AI models and allow organizations to scale analytic solutions quickly in response to new market demands or emerging data sources. As businesses become more agile and data becomes more pervasive, the fusion of cloud capabilities with cutting-edge analytics will define tomorrow's BI landscape. Conclusion. The integration of data science and AI into business intelligence is not just an evolutionary step. It is a revolutionary shift that is redefining how organizations make decisions. From enhancing predictive analytics and automating routine tasks to personalizing insights for different functional areas, these technologies are turning BI into a dynamic, real-time partner for corporate leadership. While challenges such as data quality, integration complexity, and ethical concerns exist, the benefits far outweigh the drawbacks when implemented thoughtfully. Organizations that invest in building robust data infrastructures, upskilling their talent, and adhering to ethical AI guidelines will be well-positioned to harness the full potential of next-generation BI systems. As cognitive BI and augmented analytics become mainstream, decision-makers will rely on systems that are not only reactive but truly anticipatory, providing insights and recommendations that drive continuous improvement and sustainable growth. In essence, the future of business intelligence lies in a holistic integration where advanced data science and AI converge to create intuitive, transparent, and powerful analytical ecosystems. By embracing this integration, companies can unlock unprecedented levels of competitiveness, innovation, and operational efficiency, making informed decisions faster than ever before in an increasingly digital world.